Hello world! Welcome back to the Intro to Python series. In this video, we will be covering arithmetic operators in Python 3. Arithmetic operators are used to perform mathematical operations like addition and subtraction. There are 7 arithmetic operators in Python 3: addition, subtraction, multiplication, division, modulus, exponentiation, and floor division. Let's start with addition, since we are the most familiar with it from our previous videos. The addition operator is represented by the plus symbol. Let's assign our a and b variables to 4 and 2 respectively. Let's assign another variable c to store the result of our addition operation on a and b. Now let's print C and run the script. We see that our script printed out 6, which would be the sum of adding a to b, or 4 plus 2. Now let's do subtraction. The subtraction operator is represented by a hyphen. We'll use the same values for a and b, and use c again to store the result. When we run the script, we see that the difference of a minus b is 2, which is correct because 4 minus 2 is indeed 2. However, what if we do the reverse and subtract a from b? Doing so gives us the value of -2. Python 3 can calculate and use negative numbers. When using negative numbers in your expressions that you write in your script, you still use the hyphen in front of the number you want signed to represent a negative number. Let's move on to multiplication. The multiplication operator is represented by an asterisk. Let's multiply a times b. If we run the script, sure enough, the result of a times b is 8, and the product of 4 times 2 is 8 as well. As with any of the operators, they all follow fundamental mathematical rules. If you multiply a positive number by a negative number, Python will return a negative number. And if you multiply a negative number by another negative number, Python will return a positive number. For the most part, Python 3 follows the fundamental mathematical rules that you are already accustomed to. Let's continue with division. The division operator is represented by a /. If we divide a by b, we should get 2. Let's see. Running the script again shows us that, in fact, the quotient of a over b is 2. What if we did 2 over 4 though? We see that Python can also handle floating point numbers, which are just numbers that are not whole numbers that have values after the decimal point. As you can see, we got 0.5 from dividing 2 by 4. One more thing about division I would like to show you is what happens if we attempt to divide by 0. We know that dividing by 0 results in something that is undefined or does not exist. Let's see what happens if we try to divide a by 0 in Python. Running the script this time throws an error, and that is because, as we stated previously, that dividing by 0 is undefined. Thus, Python is unable to calculate a result based on a division property that results in an unknown quantifier. Modulus is another division-related operator, but instead of calculating the quotient, it calculates the remainder, if there is one, when dividing two numbers. The modulus operator is represented by a percent sign. Let's define a new variable d and assign it the value of 3. Now let's do a mod d and run the script to see the result. We know that under normal division, a divided by d would be 4/3, or 1 1/3. However, with modulus, the result is 1 because 4 divided by 3 leaves a remainder of 1, and 1 plus 3 is equal to 4. Now let's try a test case of a mod b, since 4 divides evenly with 2. Running the script again shows us that the result is 0, which indicates that there is no remainder. An exponent, or calculating the exponential, is represented by 2 asterisks. Let's raise a to the power of b. Running the script shows us that a to the b power is 16, and 4 squared is 16. The final operator we will discuss is the floor division operator, which is, again, another division-related operator. The floor division operator is represented by 2 forward slashes. We know that with normal division, Python is able to calculate a decimal point number. However, with floor division, any digits after the decimal point are removed along with the decimal point itself. The caveat to this is that if one of the operands in the expression is negative, the result is floored, or in other words, rounded away from 0. On a number line, you would round towards negative infinity, if that helps you to visualize it more clearly. Now that you know what floor dividing entails, let's floor divide d by b. When we run the script, we, with normal division, would have gotten 1.5. But since we are floor dividing, we just remove the decimal altogether and are left with 1. Now, let's test the caveat we mentioned earlier. Let's change 3 to a negative 3 and see what the result is. As we can see from running the script, the result is actually negative 2 instead of 1, because as we previously described, on the negative end of the spectrum, we always round towards the next negative integer away from 0. There is one last topic I would like to cover in regards to arithmetic operators. I mentioned earlier that the math operators in Python 3 follow most, if not all, general mathematical rules. The most significant rule is the order of operations, aka PEMDAS. You can use parentheses in Python 3 to isolate different areas of your expression that you want evaluated first, just like in normal mathematics. Python 3 does adhere to PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction, respectively. Let's do an example where we utilize multiple operators in Python to prove that this holds true. Let's calculate a plus b times d in parentheses and square the result. From running the script, we see that the answer that Python evaluated the expression to is 100. Let's solve this manually to confirm that result. Following PEMDAS, we first do b times d, or 2 times 3, which is 6. Then we add 6 to a, or 6 plus 4, which is 10. Finally, we square 10, which gives us a final result of 100. Thus, we have confirmed that Python does indeed follow the order of operations, and we can use this fact to write more complicated expressions to solve harder math problems that we are confronted with if we want to script it out rather than do it by hand. And we're done scripting for this video. If you enjoyed the content discussed in this video, please drop a like and subscribe to show your support and help the YouTube algorithm to better interpret the channel. Stay tuned for more videos, and please provide any feedback, good or bad, we don't discriminate, in the comment section down below. Have a nice one.